Okay, today's lesson continues what we were working on last class with loans. Last class we looked at the monthly the monthly payment calculator. So we looked at this. This should already be in Desmos. You should have already put that in. If you have not or were absent, you might want to pause the video and put this into Desmos. This is this formula here calculates what your monthly payment would be based on a particular amount of money, the principal amount of money that you want to take a loan for. And R is what interest rate you get, and T is the term of the loan in years. So it might be for 2 years, 4 years, 10 years, whatever. That's what T is. And you plug it in there and it will calculate what your monthly payment would be every single month to pay off that loan within that time. Today we're going to continue with that, but we're also going to look at a different variation of the same formula in which you could actually find how long it will take you to make the monthly payment. So a couple things we want to understand here. When you are paying a loan, because the loan is accumulating interest every single month, when you make a monthly payment, let's say for example you have a mortgage and you're paying $1,000 a month towards your mortgage, with their interest accumulating every month, when you pay $100, you aren't actually paying $100 towards the balance of your loan. So, for example, if I took a $30,000 loan out, when I make my first payment of $1,000, it does not mean that now I owe $29,000. Because interest has accumulated during that month as well, some of what I have paid went towards interest and some of it went towards the balance of the loan. So it's a hard thing for people to understand. They think that if I pay $1,000 should be subtracted from the loan. And then next month I pay another $1,000 and it comes off. But the problem is that as you're going through time, interest is accumulating in the in the loan. So even though you're making payments, you're not actually paying the entire $1,000 towards your principal. Some of it is going to cover the interest that was accumulated that month. So to visualize that, I wanted to show you this table here. So this is an example of a table where the person is paying roughly $4,000 per year toward a particular loan. So if we if we take how much principal is paid and how much interest is paid, this adds up to about $4,000. So they started with a $35,000 loan. Now, if they're paying $4,000 a year, after the first year, it should be at $31,000, right? But it's not, because during that year, over $3,000 in interest accumulated. $3,291 had to go to pay interest. So that whole year of paying $4,000, only $773 actually went towards the balance of the loan. It's sort of disheartening when you think of it that way, but that's the way the loan works. But as you continue to pay year after year after year after year, the balance goes down and down and down. And as the balance goes down, the interest, because there's less money that you owe, the interest goes down too, which means that same $4,000 now can cover more and more and more of your balance. So it looks like at first you're paying it off very, very slowly. But as the loan matures and it goes towards the end of the loan, you'll see down here the very last payment. He was able to cover $3,800 of his loan, whereas only $200 went towards interest. So that's what you need to understand with that. So back to this. Okay, so there's that monthly interest formula. I made some examples down here if you want some more practice with this. So example number one, we'll don't worry, we'll come back to this formula, but I wanted to just practice with the formula that is right here. So this example one says determine the total interest owed on a 5-year $10,000 loan at 6% APR. So what that means is if you want to find the interest, you need to first figure out how much he's paying on his loan, and you figure that out by using this monthly payment calculator. So I want you to put this in there, put this into your calculator, Desmos. Put that into Desmos and put 5 years in for T, $10,000 loan in for P, and 6% APR in for R, so it's 0.06. And that's going to give us the amount of money that they paid per month. So go ahead and put that in and figure out how much he's paying per month. Pause the video, and then when you're ready, hit play. Okay, so you should have gotten, let's see if I can adjust marker. You should have gotten the monthly payment to be 193.33, I believe. Might be off by a couple decimal points, but that should be right. $193.33 per month is what she or he, whatever, is paying. So to figure out the interest, we have to take this out, just like we did last class. We have to take this out through the whole life of the loan. So since that is what she's paying per month, and she's paying it for 5 years, at that time, that per month, there's 12 months in a year, which makes 60 months in 5 years. So we have to times that by 60. So I'm going to do 193.33 times 60. And so they have paid $11,599.80. And so how we figure out the interest that has been paid is the same thing we did last class when you're trying to figure out how much the finance charges were. Interest paid and finance charges are the same thing. So obviously this number is greater than the original because the bank charged interest. And how much interest? Well, we just subtract the $10,000 original loan, okay, and you get a total of $1,599.80 in interest that was paid. So, I mean, you can do the same thing. Example 2 is exactly the same thing. 4.3% loan at $18,000. The loan is for 8 years. You'll plug it into the monthly payment calculator again. Figure out how much she's paying per month, and then stretch that over 8 years to figure out how much interest has been made. So I'm going to let you try this one on your own all the way through. Again, use the monthly payment calculator to plug in the values. That'll tell you how much she's paying per month. And then you're going to stretch that over 8 years to see how much interest she actually pays. So go ahead and pause the video, try to work this out on your own, and check back for the answer. Okay, so you should have gotten a monthly payment on this loan for $221.93 per month for 8 years. So in this case, if that's how much she's paying per month for 8 years, you have to figure out how many months are in 8 years. 8 times 12 is 96. So we need to multiply this by 96. So let me do 221.93 times 96. and I get 21,305.28. That's how much she ends up paying in the end, which obviously it should be more than the original amount. So to find out the interest paid, we just subtract the original. And what you get is, let's see here, 3,000, right it over here, 3,305.28. That's how much she paid in interest. Now, the other examples deal with the formula that is up here. So this formula is used when you already know how much you want to spend per month. So for example, if I want to buy a car, I want to buy a $20,000 car. Okay, and I know because I've been doing my budget, I've been working through my budget sheets and everything, and I know that I can afford $200 per month. Okay, if I know that I can spend $200 per month and I want a $20,000 car, we can plug that information in this formula to figure out how long it will take me to pay it off. So this is another complex formula. So I call this the length of loan formula. So you're going to want to put this into Desmos. So at this time, go ahead and pause the video and put this into Desmos. One of the things to take note is a lot of the variables are the same. This is the same capital M. This is your monthly payment. This is how much money you need to borrow. Same. This is your monthly payment, how much you need to borrow. Rate is still the interest rate as a decimal. But one thing that is new here, you see this LN. LN is not literally letters L and N. It is a function. So if when you're going to Desmos, you'll put T equals, and then you'll click on the functions button. Under functions, go over to miscellaneous. It's on your keyboard. The functions button's on the keyboard at the bottom. You'll click the functions button, go to miscellaneous, and you'll see LN. It's there. It's short for natural log. You don't need to know that, but that's what that is. So you need to put LN in there, and it's going to pop out of parentheses, and you'll just do capital M over P, close parentheses, minus parentheses, another LN, parentheses, M over P, and plug it in. Work together. Have somebody at your table work with you, help you put this in. If Miss I is there, she can help you putting this in, because this is another critical formula you have to have in there. Otherwise, you're not going to be able to do any of the problems. So get that in there. Pause the video. Get that in there. When you're ready to continue, move on to example 3. Okay. So here we are with example 3. So Claude wants to borrow $25,000. So he's going to purchase a car for $25,000. Now he's looked at his monthly budget and he realizes that he can only afford $300 a month. So if he knows what kind of car he wants to get, and he knows he has $300 to spend, and knows he's going to qualify for a certain percentage loan, he can figure out how long it's going to take him to pay off this car. So basically, in the formula, you're going to put this $25,000 is your P. That's your principal. That's what you want to take out for a loan. The $300 monthly payment that you can afford, that goes in for M. The 5.9% goes in for R. And it should solve it for T in years. Remember, T is time in years. So go ahead and pause the video, plug it in the formula, and come back for the answer. Okay, so if you put the equation in properly and put all the values in properly, you should get that time equals 8.96 years. Make sure that I have it put in there properly. Looks like it. 25,000, $300 a month, 5.9. Yeah, 8.96 years, which you should get. Now, that's really all you do. And so example 4 then looks at example 3 and says, what impact would an increase in monthly payment of $50 have on the length of the loan? So a lot of times people will look at the minimum payment and they'll just make the minimum payment every month, and that's fine. And in this case, if you make a minimum of $300 a month, you're going to pay the loan for 8.96 years. But if you could afford to do just $50 more per month, so $350 a month, you're going to see by paying more per month, you're going to pay it off considerably faster. So go back to Desmos and change 300 to 350 to see the difference in the length of the loan. So go ahead and pause the video, plug in 350, see what you get. Okay. If you put everything in properly, time is 7.35 years. Notice that if they put the if he just paid $50 more, he just cut a year and a half off the loan. So that is a huge difference. That is why it is always good, if you can afford it, to pay more than the minimum payments. Because if you pay more, it drastically decreases the amount of time that you're paying off the loan. So look here, it goes from almost 9 years to just over 7 years. That's a huge difference in how much time he has to pay the loan. So that's it. Basically, we just worked with the formula we worked with last class and then the new formula. Please make sure that you have the new formula in Desmos properly. If you don't, if it's in there incorrectly, you're not getting these answers, please talk to somebody at your table or Miss I or somebody that can help you get the formulas in there. The practice problems, I think there's 1, 2, 3, there might be like, can't remember how many there are, but basically the answers are there at the bottom of the last page, so you can check your work. But go through these problems, make sure that you are getting the correct answers. You will have an outcome quiz at the beginning of class next class. Okay, I want to make sure everybody's on the same page. If you have any questions, you can email me, or you are more than welcome to stop in during AL on Monday and get any questions answered. Thanks.